Hey guys, so some of you requested me to solve a more tricky problem on projectile motion. So here we go. We solved this problem where the car jumps off a horizontal track with velocity 8.5 meters per second, and the initial velocity of the projectile was vertical velocity. Initial vertical velocity was 0, and our initial horizontal velocity was 8.5 meters per second. So I thought about it. I think it's a good idea to just extend that problem, where now instead the car jumps over an inclined plane. Okay, let's make it a toy car. Okay. Now the car jumps over, let's say, with the same velocity, 8.5 meters per second. And let's say that the inclined plane makes an angle theta 30 degrees with the horizontal. And let's keep the height also the same, so let's keep this 0.61 meters. Okay, so this angle is also going to be 30 degrees. Okay, it's going to be the same as the angle that the inclined plane makes with the horizontal. Okay, so we have V naught now at an angle with the horizontal, and the projectile or the car jumps off the plane and then lands somewhere over here. Okay, so we're still looking for this horizontal distance, delta x. So delta x is still the unknown. Now we know that V naught is 8.5 meters per second. So V naught x is V naught cosine theta, and when you plug in, so theta is 30 degrees, so when you plug in these two numbers, you get 7.4 meters per second as the horizontal velocity, and V naught y is V naught sine theta, and when you plug in the numbers, you get 4.25 meters per second. So these are your components of velocity now. Okay, again, you have, this was 0 before, but now it's non-zero. And again, I would suggest you guys to write knowns and unknowns in the x and y direction. I'm just going to directly write down the equation that you have to use, because the situation is similar, in terms of the equation that we have to use. Of course, the velocity is at an angle, so it's different in that sense. So we're going to use this equation, delta y equals v naught yt minus half gt squared. So we used this equation before also, but we plugged in v naught y equals 0. So v naught y is not 0 now. It's 4.25 meters per second. And delta y is still negative 0.61. Okay, so delta y, let's write that over here, negative 0.61. So it's y final minus y initial. So if this is your origin, so that's 0, and then initial is 0.61. So 0 minus 0.61 is negative 0.61. Even if you take your origin over here, your initial will be, your final will be negative 0.61, and initial will be 0. So you get the same thing. I'm just going to call that h, negative h, because I want to solve this equation in terms of variables first. So let's plug that in. So be careful with this negative sign. Now if you don't plug in this negative sign, you will change the answer, because the quadratic equation will change. So negative h equals v naught yt minus half gt squared. That gives you, let's write that down in terms of a quadratic equation. So you get half gt squared minus v naught yt minus h is equal to 0. So your in the quadratic equation, your a is half of g, your b is negative v naught y, and your c is minus h. Okay, so that's your this is your a, that's your B, and that's your C. So we get like few, right? T, the quadratic equation. So you get T equals negative B plus minus square root of B squared minus 4AC. So that's the standard like quadratic formula, divided B squared minus 4AC divided by 2A. Okay. So now let's plug in these values, or at least in terms of the variables for now. So you get T equals V naught Y plus minus square root of V naught Y squared plus 4 half of G times H divided by 2 half of G. So you get V naught Y plus minus square root of V naught Y squared plus 2GH divided by just G. Okay. So that's your time. If you plug in these values, you get T is equal to, so you get it's around 0.99. So you get a negative value which is not physical. We'll discard that, and you get around T equals 1 second. So that's your time. So this is the time that the car takes to cover this whole journey. Okay. So if you want the horizontal distance, then you will use this equation. So the equation in the horizontal direction is always, for a projectile motion without a resistance, the equation in the horizontal direction is always this: delta x equals v naught xt. Okay. Now as soon as you plug in t equals 1 second, you will get the horizontal range that you want in this situation. So v naught x is, since t is just 1 second, v naught x is 7.4 meters per second. So you get 7.4 meters as delta x. So that's your delta x that we want. Okay. Now, of course, it depends on what the question says. We can explore more in this problem. We can get the height that the projectile goes to. So if you plug in Vy equals 0, so remember at the maximum height, always remember that Vy is equal to 0. Okay. So if you plug in Vy equals 0 in this equation, Vy equals V naught Y minus GT. So if you plug in Vy equals 0, you get the time to reach the maximum height. That's V naught Y over G. And that number, if you plug in the values, turns out to be 0.43 seconds. So that's the time to reach the maximum height. And so it's this time. So, and this is going to be R H. So this is R H, capital H. Okay. And if you want the whole distance, you will add 0.612. Okay. Relative to the ground. Okay. Now, if you take this equation, Vy squared equals V naught Y squared minus 2G delta Y, and if you now plug in again Vy equals 0, you get H, capital H, equals V naught Y squared divided by 2G. Okay, so Vy 0, just if you simplify this, you get V naught Y squared divided by 2G. And that number turns out to be 0.92 meters. So that's your maximum height. Now you can, and again, this is this height. Okay, if you want it relative to the ground, you add this 0.61. And you can still do more in this problem. Let's say you want a problem can ask you multiple things in the exam, for example. You can be asked multiple things. You're really asked all of these things, but it's good to explore different aspects of a problem. So you can be asked the components of this velocity just before the car hits the ground. what is the velocity at that point. Okay, so you know that at t equals so the car takes 1 second to reach this point. So so if you plug in t equals 1 second, so if you take this equation vy equals v naught y minus gt and plug in t equals 1 second, you get vy equals, so the number turns out to be minus 5.6 meters per second. So notice that you should expect a negative y component, because the y component is this, right? So you expect a negative y component and a positive x component for the velocity at t equals 1 second. So we do get that, and vx is still v naught x, right? And that's 7.4 meters per second. So if you want the magnitude of velocity, you can use the Pythagoras theorem, and then you can just take the square root of that. So you get 9.25 meters per second. So if you want this if you want to draw this velocity as a vector, it's like in the fourth quadrant, where vx is positive, vy is negative. So if you want this angle theta, that's going to be like tangent inverse of vy divided by vx, and that turns out to be 37 degrees. If you use your calculator, plug in vy 5.6, you can just plug in the positive value, and then vx 7.4. So that's what you can do for this problem. So we got vy, and then vx, we got the magnitude of velocity, and then we also got the angle that makes with the positive x-axis. This is your x, this is your y. Now one interesting thing, now this we saw that the time that the projectile takes to cover this distance, we saw that the time that it takes to cover to reach the maximum height is 0.43 seconds. So this time, the time to reach here is 0.43 seconds. So the time to reach here is going to be double, 0.86 seconds, right? So if you plug in 0.86 seconds in the equations, we used these equations. So this of course stays the same. But if you plug in t equals 0.86 seconds and then calculate the velocity, v at this point, you expect to get the same velocity, of course, in a different direction at this point, right? Because of conservation of energy. And I said that you do get 8.5 meters per second over here. So that's a good exercise for you to try. So let's quickly review. In this example, we made the car jump over an inclined plane with velocity 8.5 meters per second. The velocity had two components. Because of that, of course, in the previous situation, the situation was simpler because v naught y was 0, but now this is non-zero. We get a quadratic equation, and we solve that quadratic equation to get the time. So the time that the car takes to to complete the whole journey is around 1 second, and from that we got the horizontal range. After that, we used this equation and plugged in vy equals 0 to get the time to reach the maximum height, and we used this equation to get the maximum height. And again, this is the height above the point where the car leaves the inclined plane. And then in order to get the component, this velocity, the velocity that the car has just before hitting the ground, we plugged in t equals 1 second, because that's the time for the whole journey, into this equation, and we get the y component, and we expect it to be negative, and it turns out to be negative. And then the horizontal component stays the same. Remember, for projectile motion, horizontal component stays the same. So we get the magnitude by using the Pythagoras theorem. We can get the angle, and yeah, I guess that's it. So hope you like the video. If you have any questions, post them in the comments, and please subscribe.